Okay, if y'all would check these real quickly while I come around and check. Here's the first three. I think you can see them. What's all that? What is today? The 28th?
No. What are you saying? I think she was mean to me. She deserved it, I promise.
What about it? Really? Did you bring the right grade? Did that?
She deserved it. You see that?
Haley!
She's dropping me for a mail.
We're
Why does it have to be now?
Talking to me or somebody else?
Where's that one?
Doing the weather. Just not nice to point.
That's actually point. What is that supposed to mean?
You just pointed at it.
But he's not even looking.
In my defense, I had to go to the football game. I had to go to the football game for band, and I didn't get home until 10:30, and then I had to work all weekend. So.
Everybody's busy. Everybody's busy. All right, everybody. Shh. Any questions over 1, 2, and 4? Anybody? Okay, here's the next ones: 5, 6, 7, 8. 5, 6, and 8. Check those real quick. So disappointed. 5, 6, and 8. Check those out real quick. No, as long as your factors are the same as mine, it does not matter which one you have first and which one you have second. Those factors just have to be the same. Any questions with those three? All right. Shh. Here's 9 and 11. 9 and 11. Any questions with those? And then the last one, number 14. I'm going to show you a couple more on this page, and then we're going to move into something new today. And so here's what I need you to do. I need you to get out your note sheet for this assignment. The one that says factoring the pressure on the top. Go ahead and make sure you get it out, because we're going to jump right into that in a second. I just want to show you something before we go into that. So yesterday, or Friday, we talked about factoring trinomials, where the a value was what? Was 1. So I didn't give you guys homework on number 12, 13, but they're different, okay? So for example, look at 10. You don't have to factor this as a trinomial that has an a value that's not 1. Here's why. If you were to look at number 10, what do you notice about every term? They all can be divided by 5. So you can pull out a greatest common factor of 5. Now, if I did that, what is 5x squared divided by 5? X squared. What's negative 30x divided by 5? Negative 6x. And what's positive 40 divided by 5? Positive 8. Now, we're at a point where we've pulled out a greatest common factor, and it left us with a trinomial that could get factored again. Look, I can take that now and break it into two binomials. What times what gives me x squared? X. And then remember what we talked about on Friday? To multiply to get a positive, what's my rule? They're either both going to be positive or they're both going to be negative. So all I have to do is just look at that middle term, and it tells me in this case they're both going to be what? They're both going to be negative. So they're combining, right? We look for the two numbers that accomplish what goals? They multiply to get 8. They combine to get 6. What two numbers multiply to get 8, combine to get 6? So it has to be 4 and 2. Now, does it matter where I put the 4 and 2? No, because they're both x minus. So my answer, all the way broken down, is x, or 5 times x minus 4 times x minus 2. That's it. So I didn't give you these problems, but you could have done them. Because we did learn how to do GCF, and we did learn how to factor a trinomial when the a value was 1. And when we pull those GCFs out, it causes that to happen. Now, if you look at number 13, I'm not going to do 11 or number 12, because even when I pull out that 2, it's unfactorable. So I'm not going to spend our time with that one. But if you look at this one, we'll do one more, and then we're going to move into what we do today, which is going to be a little different. You see, this one has an a value that's not 1. However, won't every term divide by 3? So I can pull the 3 out, and now my trinomial will literally be, well, what's 3x squared divided by 3? X squared. See, it has an a value of 1. What about negative 9x divided by 3? Negative 3x. And then finally, negative 54 divided by 3. Negative 18. So when I go to factor this into two binomials, yes, it's still just an a value of 1. So what times what gives me x squared? X times x. What will multiply to get a negative this time? The signs have to be opposite, right? So it has to be a 1 a plus and 1 a minus. Doesn't matter where you put them. But you know that that tells you that we're finding the two numbers that multiply to get 18, but because those signs are different, we're finding two numbers that have a difference of what? Of 3. So what two numbers multiply to get 18 have a difference of 3? So it has to be 6 and 3. It has to be. Huh?
I don't get how it's plus and minus.
Because it had to multiply to get negative 18. When you have two things that multiply to get a negative, your only option is one being a positive and one being a negative. That's it. Think about it. The only other two things it could be is a positive and a positive.
I would know.
So
Is it which step we're looking at? First, second?
you kind of look at both, but you start with the multiplying. So you look at what multiplies to get a negative 18. Well, that's how I know one of them has to be positive and one of them has to be a negative. That's where it starts. Then at the end, you look when the signs are opposite. So y'all have already picked the numbers, right? There were 3 and 6. So then I look at the middle and I say, hey, when those two fight each other, what sign won? Negative. So negative has to go with the bigger factor. Which one was bigger, 3 or 6? So it has to be minus 6. It has to be plus 3. That's it. That is how it has to go. Okay? So there you have it. That is how you factor out a GCF.